Now see question number 4. In question number 4 they have asked us a piece of stone is tied at the end of a thread and is drilled in a horizontal circle with uniform speed by hand. Now what is the direction of the acceleration here? The body is moving in a circular path, so we can say that the direction for the acceleration, it will be towards the center of circular path. So the direction of acceleration will be towards the center of circular path. Second part, they are asking you which force provides the centripetal force for the circular motion. So the tension in the string, so the tension in the thread will provide the necessary centripetal force. That was the A part. Now moving on to the next part of the question. See the second part. What they have asked in the second part: state a factor on which the position of center of gravity of the body depends. And we have to explain this with the help of an example. So let's see center of gravity. So here you can write center of gravity. I'm writing in short. Center of gravity, it depends on shape of the body. It's given on the shape of the body, or you can say it depends upon the distribution of mass. Of the body. So remember, center of gravity depends on the shape of the body, or you can also write it depends upon the distribution of mass. Now we also have to give an example to show that center of gravity will change if we will change the shape of the body. So let's take an example of a straight rod. So we can say a straight rod has its center of gravity at its middle, or you can also write at its midpoint. So if we consider a straight rod, then the straight rod will be having the center of gravity at its middle. But now if the same rod is bent into a shape of ring, right? When this rod is bent into a shape of ring, then its center of gravity is at its geometric center. Okay, now if I show you with the help of a diagram, I am considering a straight rod, and if I ask you to mark the center of gravity of this rod, so you will take the midpoint, and at this midpoint will be the center of gravity. But if the same rod, when it is given a shape of a ring, the same rod is given shape of the ring, then you can see center of gravity will shift to the center of this ring. and here there is no mass. So that means as we change the shape of the body, the position of center of gravity will change. Okay, now let's see what they have asked in the C part of this question. In the C part, they say, what is the position of center of gravity of a triangular lamina, and then we have a rectangular lamina. Okay, so in the C part, they are asking us to write the position of center of gravity for a triangular lamina. First of all, for a triangular lamina, center of gravity will be the point of intersection of the medians, will be point of intersection of medians. Second part, they are asking you to write the position of center of gravity for a rectangular lamina. So for a rectangular lamina, it will be the point of intersection of diagonals. Point of intersection of diagonals. This was the C part, where they have asked you to write the position of center of gravity for different shapes. Now moving on to the D part. Now as you can see in the D part, they have shown you a diagram. Now this is this sloping. The length of this sloping is 10 meter, and this sloping is inclined at an angle of 30 degree with the horizontal. And now they have asked you to calculate. Now here is the force being applied. Now this force is 25, not 15 as it's printed over here, it is 25, and we have to calculate the work done by the force in pulling the body. Now see, in the first part we have to calculate work done by the force. Now you see the direction of the force as well as the direction of the displacement. See, direction of force and the direction of displacement both are same. So when direction of displacement and direction of force both are same, so we have to calculate in the first part work done by force. So work done by the force, you can use the formula Fs cos theta. Now according to the question, you can see force and the direction. See, body is moving in this direction, so displacement and force both are in the same direction. So when force and displacement both are in the same direction, so theta will be 0 degree. So you can write it like this, Fs cos 0 degree. Now force given to us is 25 Newton. Displacement, you can see force is of 25 Newton and the displacement along the sloping is of 10 meter. Displacement is of 10 meter and cos 0 is 1. So from here we can calculate work done. So work done by the force will be 250 joule. That's the first part. Now in the second part, they have asked you work done against the force of gravity. Now we have to calculate work done against the force of gravity. So if you have to calculate work done against the gravity, then you must know this height. You must know this height. If this height is known to us, then we can calculate work done against gravity using the formula mgh. You must know the height, and after knowing the height, you can calculate work done against gravity using the formula mgh. Okay, So first of all, we need to calculate this height. Now see, this is a right angle triangle, and in this right angle triangle we need to calculate height. And here you can see hypotenuse is known to us. Hypotenuse is 10. So in this right angle triangle, hypotenuse is known to us, height we have to calculate, and the angle given to us is 30 degree. Now you have to think of a trigonometrical ratio that will relate height with hypotenuse. See, height we have to find, hypotenuse is known to us, so we should think of a trigonometrical ratio that will relate height with hypotenuse. So what we can do over here, see how will we find the height. So to find the height, I will solve it here only, height. So we can use the ratio sine 30. Ratio sine is perpendicular upon hypotenuse. Value for sine 30 is half. Perpendicular means height. Height is known to us. Height is unknown, okay. And this hypotenuse, this is 10. So from here you will get the perpendicular height, that is 10 by 2, that is 5 meter. So we have calculated this height as 5 meter. Now we need to calculate work done against gravity. So for that we can use the formula work is equal to mgh. So in the second part we can calculate work using the formula mgh. Now here m is the mass of the body. So if you go through the question, mass is given 4 kg, g is acceleration due to gravity which is given 9.8, and h is the height that you have calculated 5. So using this information, mass is 4, gravity is 9.8 into height is 5. So if we solve it, you will be getting 196 joule. This is work done against gravity. This is work done against gravity. Now, third part says you have to account for the difference in part 1 and part 2. Now in part, okay, so the third part says you have to account for the difference in answer of part 1 and part 2. Now in part 1 we calculated work done as 250 joule. In part 2 we calculated work done against gravity as 196 joule. Now you can see that there is a difference in the work done. So we have to account why this difference occurs, because whatever work is being done on the body on pulling it, the same should have been the work against the gravity, but there is a difference in the work coming. So why? So you can see over here, we can say the difference is of 54 joule, and this difference is used against the friction between the body and the inclined plane. So this is the reason why there is a difference. Okay, now moving on to the next question. See question number 5. In question number 5, first of all we have to define kilowatt hour, and then we have to write how it is related to joule. So let's see the definition for 1 kilowatt hour. So 1 kilowatt hour is the energy spent, or you can say it is the work done by a source of power 1 kilowatt in 1 hour. So this will be the definition for kilowatt hour. And now we have to relate kilowatt hour with joule. So 1 kilowatt hour is equal to 3.6 into 10 raised to power of 6 joule. So this will be the relation between kilowatt hour and joule. Now moving on to the next part. The next part says a light mass and a heavy mass have equal momentum. So we have two bodies, light mass and heavy mass, both having equal momentum. Now we have to find which will have more kinetic energy. Okay, so let's see here. Moving on to the part B. So we have two bodies, light mass and a heavy mass. Now let us write the formula for kinetic energy in terms of momentum. So it will be P square of momentum upon 2m. Okay, as the two bodies are having the same momentum, so we can say the kinetic energy of the two bodies will depend on mass because they have same momentum. So from here we can say that kinetic energy is proportional, it is inversely proportional to the mass. Now why we are saying kinetic energy is inversely proportional to the mass? Because momentum of the two bodies is same. As momentum is same for both the bodies. So as momentum is same for both the bodies, so we can say that kinetic energy is inversely proportional to the mass. So it's clear from here, the body with light mass will have more kinetic energy, because you can see kinetic energy is inversely proportional, means more the mass, less will be the kinetic energy, or less will be the mass, more will be the kinetic energy. So from here we can say body of light mass has more kinetic energy. This is the explanation why light mass has more kinetic energy. Hope this is clear to you. Now moving on to the next part, C. In part C, the part C says a pendulum with bob of mass m is oscillating on either side from its resting position A between the extreme B and C at a vertical height h above A. So here, first of all, let me explain you the diagram. We have the mean position of a pendulum here. This mean position is A. Then this pendulum is oscillating on either side, and the extreme positions for the pendulum are B and C. These are the extreme positions. Okay, so B and C are the extreme positions. Now these extreme positions are at height h above the initial position A, right? The mass of the pendulum is given to you as m. So now the question says, what is kinetic energy K and potential energy U when pendulum is at position B and A? Okay, now pendulum is at position B. Now see, at B. Now we know that when a pendulum on oscillating reaches to its extreme position, it comes to rest, a momentary rest. It gets a momentary rest over here. So you can say kinetic energy at B, position B, will be 0. Why? Because the pendulum is coming for rest, a momentary rest. So kinetic energy is 0. Okay, what about the potential energy? So potential energy, now mass of the bob is m, gravity is g, and the question says that it is at a height h above the initial position A. So kinetic energy is 0 and potential energy is mgh at position B. Okay, now the pendulum will move towards the position A. So at position A, at position A, its height will be 0. In comparison to B, its height becomes 0. This is the initial level. Here, it becomes 0. So you can say that potential energy at A will be 0. So how much will be the kinetic energy? Now, by the law of conservation of energy, as there is no friction or there is no air resistance, it has not been indicated in the question, so you can say whatever will be the potential energy at B, same will be the kinetic energy at A. So at A, it will be having potential energy what it was having at B, so that is mgh. So see, at position B it was having the height, so potential energy is mgh, kinetic energy will be 0 because it will be momentary rest. Now when it moves towards A, it loses all its height, height becomes 0, so potential energy becomes 0, but the kinetic energy, it will have only the kinetic energy, and by the law of conservation of energy, whatever will be the potential energy at this point, same will be the kinetic energy at the mean position, provided there is no loss of energy because of the friction or the air resistance. It has not been indicated that there is any loss, so kinetic energy will be equal to potential mgh. This is clear to you? See, we can't write kinetic energy half mv square. Why? Because velocity is not given to us in this question. So we cannot write kinetic energy half mv square. Only height was given to us in this question. So we can write energy only in terms of h. Now moving on to the next part, that is the D part. Okay, now in D part, let's see what's the question. The D part is, now this is the D part. D part says a pulley system, that is a block and tackle system, has 3 pulleys. Now first of all, you can see it is having 3 pulleys. Now in the D part, they are saying a pulley system has 3 pulley. Now if the pulley system has 3 pulley, so remember that its velocity ratio will be 3. Okay. Now we have to draw the diagram showing the point of application and direction of load, effort and tension. Now we have to draw the block and tackle diagram for 3 pulley, that is the odd number of pulley. So when we have to draw the diagram for odd number of pulley, remember the fixed part of will be containing 1 pulley more than the movable part. So here our diagram will be, see, like this. You will draw 3 pulley system. So 2 pulleys will be kept in the fixed portion and 1 pulley will be kept in the movable part. Now we will draw the string around it like this. Load will be in the movable part. Here you will apply the effort, and this will be the tension in the segments of the pulley. Now the question says, see, direction of tension will be in the upward direction, effort in downward direction, load in downward direction. Now they say that you have to lift a load of 150. So load is given to you and effort is given to you. So as load and effort both are given to us, so we can find mechanical advantage, load upon effort. So we will get mechanical advantage 2.5. Now what else they are saying? They are saying calculate its mechanical advantage, that we have calculated. Is the pulley system idle? Now one way of checking whether the pulley system is idle or not, you can say mechanical advantage and velocity ratio, they are not equal. Remember, in an ideal machine, MA and VR, they are always equal. Here MA and VR are not equal, so you can say that this is not an ideal pulley system. The other way is you can calculate the efficiency, and if efficiency is not coming 100%, then again you can say that it is not an ideal pulley system. This is clear to you now? Now the question number 6 says, why the output energy can never be greater than the input energy of a machine. So let's see what could be the reason for it. See, because some part of input energy is used against in overcoming the weight and the friction present in the moving part of the machine. So the output energy is always less than the input energy. So this is the reason why output energy is never more than input energy. Second part says, how is mechanical advantage related to velocity ratio for a practical machine? Now remember, in a practical machine, mechanical advantage is always less than velocity ratio. If it's a practical machine, then mechanical advantage will always be less than velocity ratio. Okay, moving on to the next part. The next part says, write one example each of a class 1 lever where mechanical advantage is more than 1, less than 1. Now, here in both the cases, we have to give example of class 1 lever. Class 1 lever where mechanical advantage is more than 1. Remember, it should be class 1 lever only. Now, in the first part, class 1 lever, we have to give an example of class 1 lever with MA greater than 1. So they have asked for one example, so we can say the plier, or you can also give an example of shears. They are used for cutting the metals and all. In the second part, again it's a class 1 lever. Again it's a class 1 lever, but this time the mechanical advantage should be less than 1. It should be a class 1 lever, but mechanical advantage should be less than 1. So we can give an example, a pair of scissors. This will be our answer for the B part. Now moving on to the C part. Now let's see what they say in the C part. C part says, which type of lever has mechanical advantage always more than 1? Mechanical advantage always more than 1. So you must be knowing the answer. It is class 2 lever. You have to give a reason. And then what change can be made in this lever to increase its mechanical advantage. Okay, so let's write the answer for it. First of all, we have to name the class of lever. So you can say class 2 lever. Class 2 lever, mechanical advantage always greater than 1. Right? Then we have to give the reason why its mechanical advantage is always greater than 1, because in class 2 lever, effort arm is always greater than load arm. So this is the reason why mechanical advantage of class 2 lever is always greater than 1. Sorry, greater than 1. Okay. Next part, they say, what change can be done in this lever to increase the mechanical advantage? So if you have to increase the mechanical advantage, you need to increase the length of effort arm. So we can say mechanical advantage can be increased by increasing the length of effort arm. If we increase the length of effort arm, mechanical advantage will increase. This is clear to you now? Okay, now moving on to the next question. Okay, now in the D part, this is the diagram shown to you. The diagram shows to you, it is showing a section of a semicircular block. This is a section of a semicircular block. This is the center of the semicircular block marked as O. They have shown you three rays A, B and C. These three rays are directed towards the center of the semicircular block. Now of these three rays, ray B, they have shown you the path of the ray B. As you can see in the diagram, the path of the ray B is along the surface. This is shown to you in the diagram. Now the question says, on the diagram, first of all, you have to mark the critical angle. Now remember, whichever rays of these three rays, whichever ray will be passing along the surface, that ray will be making the critical angle. So in the diagram you can see ray B is passing along the surface, so that means ray B is making critical angle. Now angle will be between the ray and the normal. So you can mark from here to here, this is the angle of critical angle. So this we have marked critical angle. It is the angle between the ray B and the normal. So first part says you have to mark the critical angle. Now what about the second part? Second part says, see, the second part is the ray enters the block undeviated. Now why these rays are entering the block without being deviated? So as you can see, the three rays, they are directed towards the center of the block, and this direction towards the center of the block makes them perpendicular to the surface. So you can write in the second part, rays are directed, the rays are directed towards the center, of the glass block, of the semicircular glass block. This is a semicircular block. And remember, whenever the rays are directed towards the center, it makes them perpendicular to the semicircular surface. So they are directed towards the center of the semicircular block, so it makes them perpendicular. It makes them perpendicular to the surface of block, to the surface of block. And you must be knowing that whenever a ray enters a medium being perpendicular to the surface, it goes undeviated. So that's why these rays have gone in the block without being deviated, because they are perpendicular. Okay. Next, we have to write, the next part says, draw the path of ray A and C after they strike the edge XY. So here, the two rays A and C, they are striking the edge. This is the edge XY. Now as you compare their angle of incidence with the critical angle. Now if I compare angle of incidence of the ray A with the critical angle, you can see angle is less than the critical angle. So in the diagram you can see that the ray A is making angle of incidence less than the critical angle. So the ray which makes the angle of incidence less than the critical angle, so ray A will be refracted away from the normal. So it will enter the second surface and it will be refracted away from the normal. And why it has been refracted away from the normal? Because its angle of incidence is less than the critical angle. So that's why it has been refracted away from the normal. Now, if I compare angle of incidence for the ray C, so see, for the ray C here, this angle, which is the angle of incidence, is more than the critical angle. So as the ray C is making angle of incidence more than the critical angle, so ray C will be reflected back like this. So we have completed path for ray A and C. Okay, what the next they say? They say name the phenomena which the ray A and C exhibits. So as you can see, ray A. So first of all, ray A. What phenomena does it exhibits? So you can say that ray A is refracted away from the normal. So it's refracted away from the normal. Now, what about the ray C? As you can see, ray C has struck the surface and it has come back. So you can say कि ray C exhibits total internal reflection. It's total internal reflection. This is clear to you now? So this was question number 6. Now moving on to the next question, question number 7. Now the question number 7 says, how does the refractive index of a medium depends on the wavelength, and how the refractive index depends upon the temperature of the medium? So let's write the answer for this. So here we can say that the refractive index of a medium decreases with the increase in wavelength. So if wavelength will increase, refractive index will decrease. Similarly, refractive index of a medium decreases with the increase in temperature of the medium. Okay, now moving on to the next part. In the next part, they are saying a light ray passes from water to air. In the first case, it passes from water to air, and in the second case, it passes from water to glass. And we have to indicate in each case how the speed of light changes. Okay. So in B part, in the first part, they say light is traveling from water to air. So you can see light is traveling from denser to rarer. So as the light travels towards the rarer medium, its speed increases. So we can write that the speed increases. So whenever the ray of whenever the light will travel from denser to rarer, its speed will increase. In the second part, it's traveling from water to glass. Now traveling from water to glass means it is traveling from rarer to denser. So as it travels from rarer to denser, its speed will decrease. So speed decreases. Moving on to the C part. See. Now what's given in the C part? In the C part, they say, how does the deviation produced by a prism depends upon the refractive index and the wavelength of light. Okay, so let's see what can be the answer for it. In the first part, we have to indicate how the refractive index, how the deviation is affected by the refractive index. So you can write a prism with higher refractive index produces greater deviation. So more the refractive index, more will be the deviation. Second, we can say we have to tell how the deviation depends on the wavelength. So we can say more the wavelength, less is the deviation. This is clear to you now? Okay, now moving on to the D part. So let's see what they have given in the D part. Okay. In the D part, they say an illuminated object lies at a distance 1 meter from the screen. So they have given you distance between the object and the screen. It is of 1 meter. So in the figure, we can draw, let us this be a screen, right? Let us mark this as a screen, and this here let us mark an object. This is object. Now according to the question, distance between the object and screen, it is of 1 meter. So you can say that this distance is of 100 centimeter. 1 meter, that is 100 centimeter. Now what else given? Now they say a convex lens is used to form an image of the object on the screen. We are getting image on the screen, that means it's a real image. And this convex lens is placed at a distance of 75 centimeter. See, convex lens is used to form an image of the object on the screen. A screen placed at a distance of 75 centimeter from the lens. So, screen is placed at a distance of 75 centimeter from the lens. This is a screen. If we place a lens here in between, so according to the question, distance of the screen from the lens, this distance is given 75 centimeter. So if this distance is 75 centimeter, so this remaining distance between the lens and the object, this will be 25 centimeter. Okay, now see, this is the distance of object from the lens. So this distance is represented by u, and it will be negative 25. Now this is the distance between the lens and the screen, and on the screen you are getting the image. So you can say it is the distance between the lens and the image. So that distance is 75. So in the diagram we can see that V is equal to positive 75. U is negative 75 and V is positive 75. Because whatever the distance is in front of the lens, it is always taken negative, and the distance behind the lens is taken positive. So we have taken U as negative and V as positive. Okay, now the question says we have to find the focal length. So let's find the focal length of the, using this information, we will find the focal length. So let's find the focal length. Now to find the focal length, we can use the formula 1 upon f is equal to 1 upon v minus 1 upon u. Okay, v we have taken as positive 75, u is negative 25, right? So we will be getting 1 upon f is equal to, here LCM will be 75. So this will give you 1. This will become minus minus plus. 25 goes 3 times. So this will give you 4 upon 75. So f will be equal to, you will take the reciprocal. So 75 upon 4. So when we solve it, we are getting 18.75 centimeter. So this will be the focal length. In the second part, they have asked us to calculate the magnification. Formula for magnification is V by U. So here V is positive 75, U is negative 25. So magnification will be negative 3. This will be the magnification. So this was asked in the question. Okay, now moving on to the next question, that is question number 8. Okay, now in the first part of the question, they have asked us to define the second focus of a concave lens. Okay, so see the definition for the second focus of a concave lens. The definition says that second focus is a point f2. It is indicated by f2 on the principal axis of the lens, such that rays of light incident parallel to the principal axis after refraction from the lens appears to be diverging from this point. Now if we follow this definition given here and try to draw the diagram, so let's see what will be the diagram here. Let this be considered as a concave lens, right? This be the principal axis. This is the optical center. Now the question says, for a concave lens, second focus is a point on the principal axis of the lens such that rays of light incident parallel to the principal axis. So let us consider incident rays coming from this side which are parallel to the principal axis. So let us consider this ray which is coming parallel to principal axis. So this is the incident ray which is coming parallel to principal axis. Let us consider one more ray. This ray is incident ray which is coming parallel to principal axis. Now the definition says that the incident ray is parallel to the principal axis after refraction. Now these two rays will be refracted from the lens and they will appear to be diverging from this point. So there will be a point on the principal axis, and these rays which are parallel to principal axis, when they will diverge from here, they will appear to be coming from this point like this. So this ray, when this will be refracted, it will appear to be coming from this point. So this point will be termed as the second focus. So this is how we can draw the diagram for the second focus of a concave lens. We have used this definition and drawn the diagram. Hope this is clear to you. Okay, now the second part of this question. So let's see what they have asked in the second part. They say if half part of a convex lens is covered, they are covering the half part of the convex lens, how the focal length will change, how the intensity of the image changes. Now remember, if you are covering the half portion of a convex lens, it won't affect the focal length. So the question says how the focal length changes. So no change in the focal length. how the intensity of the image changes. As you have covered half of the lens, so the rays coming, they are blocked. So less number of rays will pass through the lens. So we can say that the intensity of the image will decrease. This is clear. So in the first part, they have asked what change in the focal length. So no change in focal length. There will be no change in focal length. We are covering half the lens, but we will say there will be no change in focal length. Focal length can change if we take different medium on both sides of the lens. In the second part, they are saying how the intensity of the image will change. So intensity of image will decrease. That means you will be getting an image that will be less brighter. Intensity will decrease. That means you will be getting an image which is less brighter. This is clear to you now? Okay, now moving on to the next part. C part. A lens forms an upright and diminished image. See, lens is forming upright and diminished image of an object, and this image is being formed at the focal point. It's upright and diminished. Now come to this point. If it's upright and diminished, so be sure it is going to be a concave, because convex gives upright image only once, and that too it is enlarged. But concave lens always gives upright and diminished. So along with the upright, if you are getting diminished word, then remember it should be a concave lens. So that means here we have to draw the diagram for concave lens. It is producing the image at the focal point. So let's see what type of diagram you can draw here. Okay, now to get a virtual, that is upright and diminished image, we are going to use a concave lens. Now where should be the object? Object should be far distance. So when the object is at far distance, then remember rays coming from the object, the light rays, they will be parallel to each other but not parallel to principal axis. So let us consider one of the ray going towards the focus. This ray is directed towards the focus like this, but it won't be going towards the focus, it is directed towards the focus. So this ray, after refraction, it will go parallel to the principal axis. So we have considered one ray coming from the far distance, and this ray was directed towards the focus, so it will go parallel to the principal axis. Now let us consider the second ray. Second ray will be coming parallel to the first one. So let this ray be directed towards the optical center. So this ray which is directed towards the optical center will pass undeviated. So we have considered these two rays. Now as you can see, the two rays that you are getting, they are diverging. So diverging rays can never be made to meet each other on being produced forward. So we will produce them backward. So this will go along this direction, and this refracted ray will go along this direction. So the two refracted rays on being produced backward, they meet at this point. So you will get image at the focus. See, you are getting upright image and you are getting diminished image at focus. Object must be very large because the rays are coming from far distance, so object will be very large, but image that you are getting, it's upright, and secondly it is smaller than the object and it is being formed at the focus. This is clear to you? Okay, now see the D part. The D part says state one way to reduce the moment of a given force about the given axis of rotation. Now you must be knowing that the formula for the moment of force, formula for moment of force is equal to force into perpendicular distance. So if you have to reduce the moment of a given force, see, force is given, so force is constant, you cannot change the force. Now to decrease the moment of force, you need to decrease this distance. So if you decrease the distance, moment of force will also decrease. See, the question, it is a given force, so you cannot make any change in the force. So only the change that you can make is in the distance. So here you will say that this distance, if reduced, it will reduce the moment of force. So let's write the answer for this part. So this is D part, and we are writing the answer for the first subpart. So you can say by decreasing the perpendicular distance of force from the axis of rotation. This is how we can reduce the moment of force. Okay, now the next part is, we have been given a uniform meter rule. Now it's a meter rule, that means this rule will be of 100 centimeter. Its weight is 60 GF and it is pivoted at 0 mark. And now they say, how can it be made horizontal? How can it be made horizontal? By applying the least force. And now we have to draw the diagram. See, let's see how you will draw the diagram. First of all, according to the question, it is a meter rule. So whenever we draw a meter rule, we will take a line. This is a meter rule which will be of 100 centimeters. So you can mark 0 of it here. The other end can be marked as 100 and the mid of this scale can be marked as 50. Now the question says that this rule weight is 60 and it is pivoted at 0 mark. At the 0 mark we have to pivot the scale like this. Now at the center of the scale will act its weight. You can consider F1, that is the weight of the scale. It is given as 60 GF. Now you can see the diagram shows that this scale will be pivoted, is pivoted here. Force is acting in the downward direction like this. Force is acting in the downward direction. So this scale will bend like this. It will rotate like this, means it will be getting the clockwise movement. See, clockwise movement. Now, if you have to keep this rule in equilibrium with the least force. Now, question says, now listen to this statement. You have to make it equilibrium with the help of least force. Now, to apply the least force, distance should be maximum. So that means you will apply the force at this end. And this force, that is the weight, is producing clockwise moment. So to balance it, you will apply the force at this end and the force should be in upward direction so as to get the anti-clockwise moment. So it's clear from here that we are going to apply the force in upward direction, F2. And why we are applying the force at the end? Because the question says you have to apply the least force. So for the least force, distance should be maximum. So this will be the diagram. Now with the help of these two forces, we have kept the rule in equilibrium. So by the principle of moments, here we are going to apply the moment, because this force is producing clockwise moment and this force is producing anti-clockwise movement, and in equilibrium sum of the clockwise moment will be equal to the sum of anti-clockwise moments. So let's apply the principle of moments here. So as the rule is in equilibrium, so and now first of all we will get the distance here. Now for the first force, now remember, whenever you get the distance of the force from the axis of rotation, see, axis of rotation is always at the fulcrum. So here you will be getting the axis of rotation. So for the first force, this distance from 0 to 50, so d1 for the first force, distance is equal to 50 centimeter. Now if we have to get the distance of the second force, again the distance should be measured from the fulcrum only. So from the fulcrum to the second force, this distance d2, this will be 100 centimeter. So d2 is 100 centimeter. d2 is the distance of second force. Remember, whenever you will get the distance of the two forces from the axis of rotation, it should be from the fulcrum only. Now as the rule is in equilibrium, so you can say you will be using principle of moments. So by principle of moments, by principle of moments in equilibrium condition, so here it is in equilibrium position. So in equilibrium condition you can write sum of clockwise moment is equal to sum of anti-clockwise moment. So here clockwise moment is being produced by the first force F1, so you can write F1 d1, and the anti-clockwise moment is being produced by F2, so it will be F2 d2. Okay, now substitute the values. F1 is 60, distance d1 is 50, F2 we have to get, d2 it's 100. So on simplifying it, 60 into 50 upon 100, you will be getting F2 as 30 GF. So the least force required to keep the rule in equilibrium will be 30 GF. This is clear to you? Huh? Okay, now moving on to the last question, question number 9. They say work done by heart is 1.5 joule per beat. So in one beat it is doing 1.5 joule of work. You have to calculate the power of the heart if it beats 72 times in 1 minute. Now see, let us calculate the total work done by the heart. For one beat, work done is 1.5 joule. Here the question says it beats 72 times. So let us calculate the total work done by the heart. So work done by heart in one beat. In one beat it is doing 1.5 joule of work. According to the question, we have to calculate work done by heart in 72 beats. So it will be 1.5 into 72 joule. So this is the work done by the heart. Now this much of work heart does in 1 minute. So time given to us is 1 minute. So that is equivalent to 60 seconds. So question says you have to calculate the power of the heart. So power is equal to work upon time. Okay. Here the work done is 1.5 into 72 and the time is 60. So let us calculate it. 12 goes 6 times, or 12 goes 5 times. 5 reduces it 0.3, 0.3 into 6, that will give you 1.8 joule per second, or you can also write 1.8 watt. So this will be the work done by the heart. This is clear to you? Now moving on to the next part. Next part says you have to define the term power of a lens. Okay, let's see how we will define it. So we can define the power of the lens like this. It is the deviation of the incident light rays produced by a lens on refraction through it. Now when a ray of a light is incident on the lens, it gets refracted. So the deviation produced will be the measure of its power. This is the definition for the power of a lens. Now the second part of it says how the sign plus or minus of a power of a lens in related to its divergent or convergent. Now remember, if power is plus, that means it is a concave lens, right? If the power is plus, if power is plus, then remember it is a convex lens, and convex lens is always converging in nature. So if the lens gets plus power, it is a convex lens, and convex lens is converging in nature. If a lens gets minus power, then be sure it is a concave lens, and concave lens is diverging in nature. So this is how plus and the minus sign will tell you about the converging or the diverging nature of the lens. Okay, the C part. The C part says how ultraviolet radiations are detected. We have to write the property by which they are detected, and then we have to write one use of this radiation. Okay, so remember, the ultraviolet radiations can be detected by their high chemical activity. They are detected by their chemical activity. On dye and photographic plate. So this is how they are detected. So they will be detected by their high chemical activity on the dyes and the photographic plates. Secondly, they are asking us to give one use of these radiations. So let us give the use. First of all, we can say they are used for the sterilizing purpose. We can give one more use for detecting purity of gems. They are also used for producing vitamin D in the food of plants and animals. Well, they have only asked for one, so we are going to write one only. I have mentioned two here. but in the examination you need to write only one if they are asking for one. Okay, now moving on to the next part. Okay, now the D part says give two properties of a infrared radiations which are different from visible light. You have to give two properties which are different from visible light. Okay, so let's give the two difference between these two. First we can write for visible light. So visible radiations, that is visible light, and infrared. We have to give difference between these two, and we have to give only two difference according to the question. So the first difference that we can give is about their wavelength. They have the wavelength range, it's in the range of 4000 Armstrong to 8000 Armstrong. Whereas for infrared, they are in the range of their wavelength range from 8000 Armstrong to 10 raised to power of 7 Armstrong. So this is the first difference which you can give in terms of their wavelength. Now let us move to the second one. Second one, you can say that this visible light, they are visible, you can say, or they are visible. Here you can say not visible, or you can say they are simply invisible. This is the second difference. If you want to give one more, you can give one more, but in the examination they've asked only for two, so there's no need for give the extra one. Here you can say they affect photographic plates. They affect the photographic plates. Here you can say they do not affect the photographic plate. They do not affect photographic plates. So these are the difference that we can give in between these two. Now moving on to the last part. Okay, the last part says state two actions that a total reflecting prism can produce, and then we have to draw a diagram to show one such action. Okay, let us see what two actions we can get from a total reflecting prism. So the two actions that a total reflecting prism can produce. So the first action is it can be used to deviate a ray of light through 90 degree. Second use we can give to deviate a ray of light through 180 degree. So these are the two uses we can give. There is one more use that they are used to erect an inverted image. Now we have to draw the diagram for one of these two uses. I will show you how to draw the diagram for both the uses. Let us consider a total reflecting prism. Now remember what's a total reflecting prism. When you are showing a total reflecting prism, it should contain an angle of 90 degree and then the two acute angles each of 45 degree. So this is a total reflecting prism, and now we are going to use it to deviate a ray of light through 90 degree. Now for this material, critical angle will be nearly 42 degree. Now see how it can be used to deviate a ray of light through 90 degree. We will take a ray which is coming incident on this surface. It is incident normally to the surface. So as the ray is incident normally to the surface, this ray will pass undeviated. Now, when it reaches to this surface, you will draw a normal and we will calculate this angle of incidence. Now how this will be calculated? This is of 45, this is of 90, again this is of 45, and from 90 if you subtract this 45, you will get this angle of incidence equal to 45 degree. Now you see this ray is traveling from denser to rarer. Secondly, angle of incidence is exceeding the critical angle, so total internal reflection will take place. So this ray will be directed in the downward direction, and here the angle of reflection will be 45. Now when this ray directed on this surface reaches this surface, and if you calculate this angle, it comes out to be 90. So this ray will pass out undeviated like this. So here we have shown a ray of light has been deviated through an angle of 90 degree, 45 plus 45, 90 degree. So here this is the first use. Now how to deviate a ray of light using total reflecting prism through an angle of 180 degree. See how we will draw it. Again you will take a total reflecting prism. A total reflecting prism means this angle will be of 90. These two angles will be of 45 degree each. Now we have to deviate a ray of light through 180 degree. So let the first ray strike on this surface normally like this. As the ray is striking the surface normally, so you can see it will pass undeviated. So this ray will pass undeviated and strike on this surface. Now if I draw the normal on this surface and we calculate the angle of incidence, it comes out to be 45 degree, which is more than critical angle. So the ray will suffer total internal reflection. Angle of incidence is 45, so angle of reflection will also be of 45 degree, and the ray will turn this side. This angle is of 45 degree. So you can see ray has deviated through an angle of 90 degree here. Now when the ray strikes at this surface, you draw a normal and you will get angle of incidence 45. Again the angle of incidence is more than the critical angle. So what will happen? The ray will suffer total internal reflection here also, and this ray will be directed this side, making an angle of 45 degree here. So see, ray deviated at angle of 90 degree here, then again at an angle of 90 degree here. So total it has deviated through 180 degree, and the ray strikes the surface normally, so it will pass undeviated. See? So this is how we can use a total reflecting prism to deviate a ray of light through 180 degree. It was coming in the downward direction, it goes in the upward direction. 180 degree reflection. So this clear to you?